Good afternoon, ladies and gentlemen. Honorable Chairperson, Mr. Rajan S. Mathews, Director General, COAI, distinguished speakers and delegates. It's my pleasure to extend you all a very warm welcome for joining us today for 27th edition of this magnificent show, Convergence India 2019. I request all of you to please silence your mobile devices. I would take this opportunity to briefly introduce our chairperson, Mr. Rajan. He is the Director General of Cellular Operations Association of India, COAI. Prior to joining COAI as DG in April 2010, Rajan served in many senior executive positions such as CEO, COO, and CFO of such major companies as AT&T Wireless, Birla AT&T, which is now Idea, Telerago, a JV of NTT, Docomo, Afghan Wireless, etc. Mr. Rajan specializes in international operations and startup ventures, turnarounds, mergers and acquisitions, and venture financing. I would like to invite Mr. Rajan to come forward and briefly introduce our panelists and take over the session, Vision 2020, Making India Ready for 5G Adoption.
Sandeep was Country Director at Viavi Solutions, formerly known as JDSU. And in his tenure at Viavi, JDSU, he was instrumental in strategically transforming the organization towards a customer-centric modeling focus, enabling customer businesses and services. He's held several strategic roles at global level, ranging from sales, marketing, setting up of offshore development centers at Agilent Technologies, Reliance Communications, Wipro Technologies, etc. Sandeep holds a bachelor's in electronics and telecommunications, senior management diploma from IIM Calcutta, and he has a great passion to create value for organizations, business transformations, synergizing sales and marketing. That's Mr. Sandeep Kapoor. Sandeep, please welcome Sandeep with a sort of applause for him. Thank you. Next we have, let's see, Raymond Lee. Yes, Raymond is the Director of Applications of Engineering, EXFO, Asia Pacific Private Limited, India. He's involved with the test and measurement industry for nearly 20 years. Raymond has extensive hands-on experience working with telecom service providers, mobile operators to ensure first-time right deployment, especially involving the state-of-the-art technology networks. The area of specialty and technical know-how include high-speed transport, which is 40G, 100G, 400G, SDH, OTN, optical fiber, so you can ask him what all those alphabets mean later on. He's at Carry Ethernet, triple play services over copper and FTTH. He has data center transport experience, more recently NFV, SDN, cloud-enabled automation, and big data analytics experience. With EXFO for over 12 years, Raymond is instrumental in driving the company's technical innovation, as he is APAC regional technical lead and responsible in identifying latest market trends to aid in innovation, next-gen products. In his current role, he consults networks operators and their contracts across APAC based on global best practices on testing. Raymond is a seasoned EXFO speaker, regularly appears in major trade shows, conferences in the region, and he holds a degree in telecommunications and electronics. Please welcome Raymond. Now, next we have very quickly Mr. Parag. He is the Vice President, Government Affairs, Qualcomm India and South Asia, India. Parag is the Vice President for Qualcomm India and South Asia, has been with the company's key regulatory and policy interface for Indian subcontinent and the region since January 2005. Wow, Parag, that's a real veteran in this space. His role includes forging lasting relationships with regulators, industry, and the Department of Telecommunications, apart from helping establish Qualcomm's leadership position as a pioneer and innovator in mobile wireless technologies globally and in India by creating a sphere of influence among key government, industry, media, civil rights champions. Mr. Kar is a key member of Qualcomm India's leadership team, works closely with all stakeholders to realize the company's vision and take the benefits of mobile broadband to a large base of Indian consumers, in particular to 1 billion Indians and beyond, with advanced mobile wireless technologies like 3G, LTE. Mr. Kar has been working closely with the DoT and other industry bodies on policy and regulation. He's aligned with international best practices and brings the benefit of global experience that relates to the Indian context. Mr. Kar has over 22 years of experience in telecoms industry, And prior to his appointment at Qualcomm, he was responsible for business development of broadband, convergence technologies, both wireless and wireline, at Lucent Technologies in India. And before that, he was with the Indian Railways and responsible for the successful completion of various telecom projects in the railways, holds a bachelor's degree in electronics and telecommunications engineering from the Regional Engineering College, Bhopal, master's degree from the Indian Institute of Technology, Delhi, is an expert and thought leader in the industry. Please welcome Mr. Carr. We have then Mr. Rajat Mukarji. Rajat is an old compatriot, friend in arms in various companies in India. He's the Chief Corporate Affairs Officer for Vodafone Idea Limited India. Rajat is a full-time advisor with Vodafone Idea. Prior to his current role, he was the Chief Corporate Affairs Officer at erstwhile Idea Cellular, been with the company since its inception in late 1995 when he joined the erstwhile Birla AT&T organization. He's headed various functions in marketing, business development, customer operations before taking charge of corporate affairs in the year 2003 at Idea. In a career spanning over 30 years, he has witnessed the hurly-burly, I can say that again, of the telecom regulatory environment in India and is happy to have been part of the continued growth in the sector. Mr. Mukarji has managed the company's relationships with external stakeholders such as government departments, regulators, media and industry, such as COAI, GSMAs, FICCI, etc. Please welcome Mr. Mukarji. Thank you. With that, I'm going to ask Mr. Mukarji to make his presentation, and then we'll go over to the individual speakers. Please, Rajat.
Good afternoon, ladies and gentlemen, and thank you, Rajan, for that introduction. Today's session is on a Vision 2020, and periodically, every now and then, we have these sessions where people are asked to discuss their vision for the next 5 years, 10 years, or whatever. This is the first time that I'm being involved in a discussion where we have a vision for the next year. And it becomes a bit of a challenge because, every 10 years or thereabouts, for all of us who have been in the technology business, 1G migrated to 2G, became 3G, became 4G, and now 10 years after the introduction of 4G, the expectation is that 5G is going to happen. So by extension, 10 years from thence will be 6G. Will it? I don't know. But 5G is touted to be the next bellwether standard in overall wireless communication systems. And it is these wireless communication systems that has transformed many things in the world around us. Communications is just one part of it. Connectivity is just one part of it. But life, the way we live it, death, the way we control it, the Sustainable Development Goals of the United Nations, there are 17 of them. Many of them have direct linkages into mobile telephony and how it is used and developed. So mobile telephony is brilliant. I can vouch for it. I've been in the system for so many years. And then when I joined the communications industry, as Rajan was mentioning, way back in 1995, I recall a survey which was conducted. We were, at that point of stage, mobile telephony was in its infancy. And we were trying to figure out what were the broad elements that would make a customer get into this category. And we discovered there were 3 broad capabilities and propensities to manage. One was productivity, one was convenience, and one was safety. Now the curious thing is, 25 years later, those 3 still remain the key contributors to entering this category. Forget about just entering the category. Once you're in the category, remaining in the category, and how this category gets used is through productivity, convenience, and safety. It hasn't changed one iota in the last 25 years. It's unlikely to do so in the future as well. But after 25 years, India today is ripe and ready for the next introduction of whatever generation of technology we want to call it. There are today approximately 1.2 billion connections in India, okay? Give or take, because it keeps changing every month. Roughly 50% of this community or connections are already internet enabled. And the average data usage is presently, and these are all data points coming from the TRAI, the average data usage per connection is approximately 8 GB. Compare that to about less than 2 GB just over 18 months ago. That is the phenomenal uptake which has taken place and the adoption of data usage by the users. So there's no question about the fact that the next leap into next 5G looks both inevitable as well as promising. But before we open our arms wide and say, come, let's embrace the new 5G, let us remember that there are issues which have to be examined. And for a minute, let's look at the present environment. Is this the right environment for us to talk about the new technology and the growth and how it will flourish? Rajan introduced me by saying that I have seen the hurly-burly. I'm certainly no naysayer as far as the march of technology is concerned. But, you know, right from the basic 2G to the current 4.5G, because, you know, 4G with MIMO is really 4.5G, I am confident that the next leap will also be made. But, and there is always a but, the present financial health of the industry is a major cause of concern. Revenue down nearly 30% in the last 2.5 years, approximately 10 quarters or thereabouts. Operators have either merged or exited, and we now have only 4 players left. ARPU down over 40% in the same period. And the overall debt burden of the 2 larger players is not just extreme, it's extremely painful. Now, let me ask you a question. In this kind of a situation, is it possible for a large amount of money to be committed to additional capex? So let's park that question for the group to take on a little later. Nevertheless, there have been some positives. There is a National Digital Communications Policy, 2018, which was released just a couple of months ago, which makes very bold statements and intentions. Connect India, Propel India, Secure India, right? But it says it has to be done by 2022. Now, assuming for a minute that this was a document which was released in 2018, and you've got a horizon up to 2022, and now I'm talking today, Vision 2020, there's a little bit of a gap here. But nonetheless, I think we are on track, and it's more than likely that the 2021-22 time frame for 5G looks more reasonable. Because, in the meantime, we need about $100 billion of investment in the overall digital communication sector. We need to create an IoT ecosystem for nearly 5 billion connected devices. This is just an indication of what the size of this market could be. We need to be able to create jobs for over 1 million people in this sector, and therefore, apart from the Connect India, Propel India, and Secure India, we also need to develop a Skill India, a Make in India, and possibly standards for India as well. So, All these and more is work in progress. And until these things really come together, it is unlikely that the vision of 2020 for 5G is likely to be realized, leave alone set to flourish and prosper. Another thing that also tends to get forgotten. We jump forward and move into the next technology, but we forget about the backward integration and the people who are behind us. We've moved with a great deal of fervor into 4G, and it's been brilliant. But there are still nearly 30 to 35% of the entire 1.2 billion connections which are still sitting on 2G, or maybe 2G and 3G. Now, if we jump into 5G, are we likely to create another pool of people who are going to be left behind? We have to be more mature from a policy-making standpoint to realize that we cannot leave those people behind. I believe that today we are in danger of doing just that, and we must not repeat that mistake. Some questions that we need to discuss today are: how are the citizens of India going to get this 20 Gbps and upwards speed which is promised by 5G? The adoption is going to require investments, as I was saying, but it also requires vast amounts of spectrum. When I use the word vast, I'm using it in relation to the quantum of spectrum that currently exists with all the operators. Much, much larger chunks of spectrum are going to have to be made available. Do we have it? Of course we do. We have it in plenty. But will we be able to provide it to the industry at the right price? And the important thing here to remember is whenever there's an investor who comes forward to make an investment, there is a certain amount of that investment which is earmarked for spectrum purchase and another for capex. Now, if you take too much for spectrum, the resultant effect is that you have less in hand for capex, which will impact your network, potentially quality of service, and then therefore the experience for the customers at the end of the day. So when a policymaker is in place, he has to be able to calibrate this in such a way that A, he can anticipate the quantum of capital which is required, and build a model which allows for the spectrum auctions to not go beyond a certain threshold point. All this time, we have worked on the principle of a reserve price, and then everybody has battled their way up from there. I'm not going to go into too much detail because Parag is he's got the adequate skills to be able to give you more details about exactly what happened and how it happened in the last 3 or 4 auctions. But what we may need to be looking at is a cap maybe, and subsequently some kind of a logic building downwards so that there is sufficient money left to build the network, and that will generate the revenues, which is where the government will earn its money from, because after all they are in a revenue share arrangement. So the method of billing has to be relooked. There are several other aspects as well. Products and services, however, have already come up to a certain level. But as soon as you start getting something which is as fast as 5G, you're going to have also additional products like M2M services, IoT services, which require high latency or maybe sometimes even low latency, depending upon the nature of the product. Either which way, these are factors which have to be taken into consideration when the policymaker sits down and determines what is going to be the pricing mechanism for spectrum, and to determine what that vision of 2020 is going to be, and to determine if your National Digital Communications Policy 2018 is going to become a reality or not. The policy also talks about the possibility of relooking costs for the industry. It's important that these costs be looked at because, as I was saying, the financial condition of the operators today is an area of concern. Regardless of what may happen, we need to ensure a level playing field among all operators and allow the normal market and competitive situations to thrive. If that happens, I am confident that not only will we as operators benefit, not only we as a country will benefit, but each of one of you as users will also benefit from the next wave of technology, which is 5G. Back to you, Rajan. Thank you very much.
Thank you, Rajat. The session is talking about getting ready, or India ready for 5G. And I think Rajat appropriately highlighted the opportunities, but also the challenges, right? The 100 billion that has to be raised in order to make a lot of this a reality in terms of NDTP, which is the National Telecom Policy, Digital Telecom Policy, talked about IoT, and then raised this interesting aspect of spectrum and the quantum of spectrum and the pricing of spectrum. And I know no better person to talk about spectrum than Mr. Carr. Parag is being the conscience of the industry when it comes to spectrum issues. And we're very glad that he's here because he's got a really detailed understanding, but also a very high-level understanding of what it's going to take India to deal with the legacy issues of 5G, because I think we've become captive of some of what has gone on before us, vis-a-vis auctions and auction pricing and CAG headlines, and now moving into this brave world of 5G, where we're talking about 100 megabits of spectrum per operator at a minimum, right? Clearly, if you continue to want to price it the way we've been doing it, it's a non-starter. So, Parag, if you could just take us through, from your perspective, the issues that you've been dealing with and keeping in focus, hey, we are getting to go into this brave world of 5G. Spectrum is a critical component of success. Tell us what you see.
Thanks. So I can be here, right? There is no need for me. But I can. Yeah, okay. So thanks, Rajan. It is very interesting, you know, what happens that whenever a new technology is on the horizon, you know, we kind of get hypnotized by the technology, right? So that's the way we always react. We have seen in past also the same kind of reaction with when 2G migrated to 3G, 3G went to 4G, and not only in the telecom, but if you look at any other dimensions of business, you will find that the same kind of excitement exists. Now, technology per se is not an end in itself. We have to understand that, right? It is actually a tool for business, right, to deliver value. And the value is being realized by the consumer. In return, the business earns money. In the process, it makes profits. And the whole cycle kind of continues like that. Now, one needs to understand, before I dwell into spectrum, one needs to understand that what kind of empowerment 5G brings on the table. Because without understanding that, the whole discussion doesn't really have any context, right? It doesn't have any meaning. So let's understand what 5G brings on the table and how it is different from 4G. Now, whenever we talk about technology, especially from 3G onwards, right, it is all about efficiency of utilization of spectrum, right? To able to do more data and able to get more services which are data-centric. Now, 5G also does that, but there is a difference, right? Now, in order for you to understand 5G, you have to realize that when we moved to wireless technologies, we were earlier, right, had an experience of wireline, right? And the wireline experience is quite different from wireless. How it is different? That if you have a wireline connection in your home, typically what happens is that if your neighbor is using the same kind of technology and the same cable or the wires which are running on the same cable, and if he's downloading a huge amount of data, your experience does not get hampered by his downloads, right? Because the line is nailed up connection. It kind of connects to the switch directly, and there is no interference between anybody using the system simultaneously along with you. Now that experience, right, which we get in wireline typically doesn't exist as you move to the wireless technology, because wireless technology, the whole access is kind of shared among different users. Like for example, in a base station, if you have multiple users using the base station, that depending upon what is the intensity of usage, your experience also kind of varies, right? And that's where you find that, the data concentration or the usages kind of, the speeds kind of go down, right, as the usages increases. But interestingly, as we have moved from 4G to 5G, this kind of distinction between wireline and wireless kind of fades away. And that's the empowerment 5G brings on the table. And this is not talked about so much, and therefore it is very important for me to basically talk about this first before I take the spectrum issues on the table, is that 5G, what it does is, it tracks an individual user, and using different technology means like beam steering and segmentation of the spectrum into multiple paths so that the channel limits does not become the bottleneck, right, of the channel. Channel is basically a capacity of the channel, the maximum theoretical capacity of the channel. It doesn't become a bottleneck. So what you do is that if you have got 20 users using the channel simultaneously, the average throughput does not get impacted. So you kind of get a wireline kind of experience in 5G. That's the distinction. That's a very, very important distinction. That's why 5G is so exciting to the operators, right? And as well as to the users, right? So that is what 5G is bringing on the table, and because of that, you are going to get a different kinds of services, which you probably are not able to experience in wireless technology. For example, video downloads, able to do streaming video, right? And let's say video on demand or extension of OFC through wireless. These are the capabilities which 5G brings on the table. Now, in order to bring these capabilities truly, what you need first, the efficiency of the channel becomes very, very high, which is enabled through 5G, and you need huge amount of spectrum, right? And the current amount of spectrum which already exists for 3G and 4G is not going to be sufficient. Now, that is why the characteristics of 5G spectrum is quite different from what we have seen in case of 3G and 4G. And there is a clear-cut distinction, because in case of 3G and 4G, you have seen that the spectrum is less in quantum and it is in the lower frequency bands. And the reason it is in the lower frequency band is because what you need to do is that you are optimizing on coverage, right? Your aim is to put as less number of base stations as possible. That is what your aim is, and that's why the lower frequency band, since it carries far, and therefore your focus is all there in the lower frequency band. But the problem with the lower frequency band is that the quantum of spectrum is limited in the lower frequency band, because you really don't have that much amount of spectrum. So that's kind of a conflicting kind of requirements, that since you need more spectrum and your coverage becomes better in the lower frequency band and you don't have spectrums, and what do you do? So you need to go in the higher frequency band. But as you go in the higher frequency band, there is a conflict that you cannot carry forward, right, distances. So what 5G does is it actually has innovative mechanism, right, to able to overcome that, and that's where, the benefits of the higher frequency band from the point of view of quantum of spectrum is realized, as well as the deficiency as far as coverage is concerned is somehow mitigated, right, with 5G technology. So therefore, because you need spectrum in the higher frequency band, the debate on Indian spectrum, right, is kind of gets focused in the millimeter wave. And today, if you see, the TRAI has opened up, right, at least recommended the 3.5 gigahertz band, right, which is a new band for 5G. But I believe that that won't be sufficient, because the quantum of spectrum in that particular band is 300 megahertz, and that too, it is kind of fractured in between, because it is not contiguous 300 megahertz band. The 20 megahertz spectrum is used by Department of Space. So there is no continuity on that spectrum, and that won't really suffice the requirements of the video on demand services that I'm talking about. So what you need the spectrum in the 26 gigahertz band and the 28 gigahertz band, and there is a lot of debate which is going on in these two bands between the Department of Space and DOT to able to extract maximum spectrum for the operators. Now, so the spectrum is going to be on the higher frequency band if you really want to get the maximum benefit for 5G. So therefore, since the quantum of spectrum is huge, it's like gigahertz of spectrum, the same kind of criteria that you adopt in pricing spectrum, right, is no longer going to be valid. Right? You need to come out with a new kind of pricing mechanism for the higher frequency band because the per megahertz pricing is going to break away. Let's say, if you see today the per megahertz price that you have used in the 1800 megahertz band or the 700 or any other megahertz band, you see there's a huge amount of price. See, 1800 is around 3,000 crore to 4,000 crores per megahertz, right? And the 700 is 6,000 crores per megahertz. You can't apply those numbers, right, in the higher frequency band. Even if you look at the 3.5 gigahertz band, the price today, right, which TRAI has come out with, if you take the FDD equivalent, is roughly 900 crores per megahertz. And internationally, the spectrum is priced as 100 crores per megahertz. So you can imagine that kind of difference between the pricing which exists between international market and what we have done in India. Now, the question comes that why we have the spectrum prices so high. It's very important to understand this point. Why India is completely, there is no correlation between our spectrum price and what we have seen in international markets. The reason actually is historical in nature. We started with the 3G auction in 2.1 gigahertz band in the 2010, and that somehow had become the reference price. And we are fearful of the fact that we can't really go down on the spectrum prices which has been realized in earlier auction. There is a scare, people are scared, right, to do that. But when you do analysis as a regulator, as a logical regulator, a rational regulator, there has to be some sanity in pricing of spectrum, and there has to be some logic on how do you price spectrum. Fortunately, TRAI realized that there needs to be some kind of framework in spectrum pricing, and they actually have a framework. It's not that TRAI doesn't have a framework. So what kind of framework exists, right? So what they have done is they have actually created various models. So there are multiple models which TRAI has used, which is a ground of valuation. It is not just referring to the past auction prices. So those ground of valuation, if you use for pricing spectrum, the problem is resolved. There is no need for you to link spectrum auction price to past auction because whatever happened in past, if you consider that as a reference, then you cannot really use any innovation in pricing of spectrum. Now somebody may say that what is the point, what is the problem, right? Using the past references as pricing spectrum. You can't do that because that is what the market basically paid for a particular band. The problem is the following. If you look at the auction design, you will see that the auction design doesn't have any mechanism, right, inbuilt into the auction which kind of penalizes misbehavior in the auction process, irrational bidding. Now, if everybody knows that if you are going to design an auction without creating such kind of safety walls which prevents a person or an operator to bid irrationally, the others will be forced to match the price. What we have seen in case of pricing also of services. If you are going to price services at a particular level, a competitor will match the price. This is the norm. But the players who actually were responsible for pricing spectrum very, very high have now gone out of business, right? So now the point here is that that's the penalization which should have happened in the auction design itself. What would be the penalization? The penalization is very simple, that if you overbid in a particular auction, the next time there is no guarantee that the price is going to basically carry forward in your future. The prices are going to be ground of valuation. And the ground of valuation is already exists today. Today, TRAI has a model for doing ground of valuation. So if you do that, then everybody will be fearful of the fact that they won't bid very high. And if they don't bid very high, the prices are automatically going to get corrected. Because there's going to always be a correction which will happen in the next auction, which will be based on ground of valuation. Now, this does not exist, and that's why the spectrum prices have gone haywire. It's gone spiral bound, and that's a major defect in our auction design. Now, coming back to ground of valuation, right? You may claim, the TRAI may claim that we are doing ground of valuation. Very good, no problems. But if you look at the models in the last recommendation which TRA has given in 2016, they have come out with various models for ground-up valuation. And I have looked through these models very, very closely. And I find that if you are going to use the models for calculating ground-up valuation, then it won't be possible for those models to throw prices which are very dissimilar. How can you have a model throwing price of 3,000 crores and another model throwing a price of 1,000 crores? How can it be possible? It is not possible, right? Statistically, we all know, it's a science, that when you have models throwing out such dissimilar prices, you cannot use mean. You cannot use averages. That's not the way to price, do aggregation of various models. You should use median as a method of aggregation. So first, TRAI's models have dissimilar prices, very, very dissimilar prices. And the second problem that TRAI's model has, that they have used mean to aggregate prices. So that's the problem with the model. And the third important problem is that wherever there is a reference price which existed in the 2015 auction, they have disregarded the model completely. What they've done is that they have simply inflated the last auction price using the SBI PLR number, which is 1.15 times, and simply put the price as the reserve price. So the difficulty is that the model hasn't been used in 90% of the cases, and wherever the model has been used, the model itself is wrong, from the point of view of aggregating the values which has come out. And another important point is that the assumptions are not there in the recommendations. So how do you check whether the models actually have been properly evaluated? That is the whole purpose of consultation. The consultation is not a one-sided affair, Consultation is a process of a teamwork between the industry players as well as the regulators, so that if there is a mistake which has happened, in calculation, those can be corrected. But that has not taken place. So what I'm basically trying to sum up here is that rather than going into the details of the nitty-gritty of technical problems of spectrum, etc., those are very, very long discussions, a lot of time will get consumed in the process. I would like to basically say that one doesn't have to plead, to get the prices down. The prices will automatically get down if you adopt a rational approach, And this is what the economists do. It's an economic problem. It's not a problem, which is, difficult to solve. So if you look at all these aspects, it will be very easy to kind of fix the spectrum price. And the allegations that, there has been favoritism to the operators, in terms of, some kind of windfall gains to them is going to wither away, because it's an economic problem. It has got nothing to do with politics. Because as long as you continue politics in business, ultimately the business is going to react and you will not be able to fulfill your political dreams. What is your political dreams? It's expansion of coverage. And the expansion of coverage cannot be done unless there is a surplus in, cash flow available for investments. And then it is also important to keep multiple players available in the market, If you are going to make only one player so powerful, then what will happen is that pricing power is going to be lost from the point of view of consumer. Consumer won't have that flexibility of switching operators and getting the most competitive price in the market. So anyway, I'll stop here, Sorry to... Yeah.
Thank you, Parag. I think you've laid out quite cogently some of the challenges as we move towards 5G in terms of if you don't fix the pricing problem. The good thing is that we've moved away from quantity being the bottleneck, in the sub 1 gig, That used to be the normal complaint. Look, and what would you expect when you constrain demand? Of course, the only give in the variable is pricing. So that's the equator. And so one ought not to be sort of surprised, in addition to some of the flaws in the actual bidding process. So going forward, talking about, hey, we've got to really look at this auction mechanism and the pricing methodology that is adopted in terms of saying, look, unless you fix this, so quantum is there, especially as you suggest, if you move over to the 26 gig to the 36 gig range, which is internationally where people are going. And by the way, the high-level 5G forum did recommend that, So they did recommend. So I think from a national telecom policy perspective, that's not even an issue, So again, government, I think, has said that they are going to do auctions sometime in June of this year. So we'll wait to see what happens. So with that, let me go over to Sandeep. Sandeep, from the marketing side, India getting ready for 5G. What does your crystal ball tell you?
Good afternoon. Thanks, Rajan, for a good and very contemporary question which is in everyone's mind. So, a couple of years ago, if we see, 5G was more of a vision, 5G was more of a hype. But with the release 15, 3GPP has really come out with a beautiful set of standards which has make 5G a reality. Beautiful thing about these standards is that these standards do not talk essentially about the speed, about the latency, about the spectral efficiency. These standards also talk about the business cases, very flexible business cases which can be applicable for different industries. So that is one of the key things which has come up differently in 5G standards. And we will have some more details about all these use cases for different industries in release 16, which is due in end of FY19 or calendar year 19. So Keysight Technologies, my company where I work, we also conducted very recently a survey across the industry players, a global survey which has been commissioned to understand the interest in terms of 5G adoption, 5G deployment, as well as what are the challenges, drivers, etc. for 5G. And we had quite interesting outcomes from that. So it was a global study. So nearly 54% of the companies which were surveyed, they have made a clear expression that they would like to, they will be deploying or rolling out 5G network and services in next 12 months. So that is the type of situation. Now this, in India, it may be slightly different because of the spectrum issues and fiber issues, but this is a general global thing which is going on. And there were some very key other takeaways also. So one of the interesting was, for what are the key drivers? What are the key drivers for 5G? So interesting thing was, after telecom service providers key, driver, second was about the technology-based industry driver, third major driver was that financial industries, financial services industries is going to be the major beneficiary of 5G. So this is another one of the things. From enabler perspectives, the top three drivers which are going to be, one is of course network speed, second one is faster, greater IoT enablement, and third one, again interestingly, connected car proliferation. So these were some of the outcomes or some of the results which we found in the surveys. Now I'll talk about a few top three challenges which service providers are, I'll say, toggling with, or they are just toying with, that how do we implement and roll out the services. So first challenge is about spectrum usage. Now from spectrum perspective, there is a sub-6 gigahertz spectrum which is earmarked for 5G, and then there is a millimeter wave spectrum which is earmarked for 5G. Sub-6 gigahertz spectrum, yes, all the service providers will get new frequency bands for providing standard mobile services and other services also. So this will improve their efficiency, this will improve their transmission capacity, and this band can be very useful for providing sporadic low data rate IoT services and reliable low latency communication. So this is something which will be really useful for them. The real challenge will come in millimeter wave bands. Now in millimeter wave bands, there will be a lot of problems in terms of handling those higher frequency for this purpose. And for higher bandwidth and speeds which will be greater than 10 gigabit per second, high frequency signals, they need to be formed into a very narrowly focused beams to avoid channel loss. So this is something which is very, very important from spectrum usage perspective. Second key channel is about radio access technologies. Now this is very important. 5G based stations, they support greater than 100, they support massive MIMO, so which means they support greater than 100 antennas, and all of them can transmit a very unique data stream. So there's an array of 100 antennas, they can transmit very unique arrays. So this will, and further technologies like carrier aggregation and multi-stream MIMO and higher modulation techniques higher level modulation techniques, these can really help in improving the spectral efficiency, and this will really decrease the cost of delivering per bit data. So as per some analysis by Ericsson, if 5G networks are rolled out in a proper way, the cost of delivering per gigabyte will be 1/10 of the cost of delivering 4G. So that is the way. But again, this is not simple. This requires a very, very clinical planning, very, very surgical analysis of what applications need to be delivered where, and very, very rigorous testing. Third challenge will be RAN topology. So RAN topology will undergo a major change as compared to 4G network. There is something called multi-access edge computing, which means shifting of the computing to the edge of the network, which is quite different on the 4G network where it is more of centralized. So there has to be a very real balance which operators need to draw between price and performance so that we can really see where to have edge computing more effectively, depending if it is a special industry grade services or if there is a different type of standard services. Now I'll talk about 3 business cases, which are the key challenges that how are they going to make money. So first one is, and these are some of the business cases which are being tried out in different parts of the world. So first one is fixed wireless access. For sure, this is very, very crucial, and this is going to be very, very important in case if the connectivity is to be provided to an enterprise building, which is slightly difficult from fiber reach perspective, which may be very, very common in India, that fiber access may be very expensive. So with a single rooftop antenna, a lot of users within the same building can be served. So fixed wireless access can be useful for that. Then fixed wireless access is also going to be very useful for apartments and high-rise buildings where there are so many users in the same cluster. So these are some of the use cases, and in fact, Verizon in US, they have already done a pilot project for fixed wireless access in 11 cities in US. So, and they are doing further rollout in next higher bands of 28 gigahertz and 29 gigahertz in coming few months. Second business case is multi-rate or variable rate data speeds and latency. Now this is something very interesting because all through the years what we have been experiencing, okay, you take 50 gigahertz, 50 gigabit pack, and this is the price, and that's it. Now with 5G inherent technologies like carrier aggregation, massive MIMO, multi-stream MIMO, operators will be able to provide variable rate, variable speeds, variable data speed services to different subscribers, different customers based on the data plans. And there will also be possibility of variable different latency also, depending on the which plan you're subscribing and which type of application you need. So this is something which will be really a game changer. And something like network slicing. This will further enable operators to provide SLAs also for the services which they provide. So Parag talk about some high-speed services like 4K TV is something for which all these SLAs will be very important, or what you can say in terms of virtual matches or virtual games which are going, if you want to participate in the games, in the matches, so this with virtual reality type of things, this thing will become really possible. Third key business case is network as a service. Now we have been hearing about MVNO, and again network slicing technologies. This will enable operators to partition the capacity of their network, and that can be subleased to another MVNO type of player who can be focusing on a specific area. Now, for example, let's take care of example of smart city projects in India. Now, this project can leverage the 5G networks of an Airtel or a Reliance Jio or a Vodafone Idea, and they can further be leveraged, subleased to an MVNO, which will be focusing on specific areas, say industrial IoT. So those are some of the use cases which operators are really working, besides the key driver, the biggest driver for the 5G, which is demand by consumers for higher speed and higher lower latencies. So from Keysight's technology perspective, we are world's largest electronic test and measurement provider. So our revenue is $4 billion. And we work very, very closely with all the 5G providers. We are in fact having highest market share in terms of 5G test and measurement solutions. And we work with all leading chipset providers and other base station providers in the world. So we have an expert of teams who have written multiple white papers, multiple solutions, and multiple application notes about how to deploy 5G technologies and what are the different challenges. So this is a Keysight book. This is a compendium which we have come up, which is called Innovate for 5G. So this will give a lot of information and knowledge about the white papers and different type of application notes. This is not essentially focused around our products, but this is generally a good provider of so much of knowledge. So you can visit our booth in Hall 9 and you can take copy of this book. And if this book is not there, you can leave your cards and we will send it to you. Thank you very much.
Thank you, Sandeep. Again, a couple of points that he made, that looking at your crystal ball, e-commerce and mobile payments and, autonomous cars kind of out there on the horizon, plus service, network as a service, network slicing, edge kind of computing, all of the things that you see becoming the necessities as you move out into the 5G world. So again, thank you for highlighting those. Now let me go over to Raymond. Raymond, you've been in the transport side, at least from your own experience, as far as EXFO is concerned. Sort of explain to us what the company is involved in, what you're doing in the transport side. We've been talking about fiber, and Sandeep talked to us about, hey, you fixed to home. We're going to have to use spectrum. So tell us what's on your mind.
Right. Hello, good afternoon, everyone. I think my session here, after considering and looking at all the panels introductions, I'd like to spend some time to talk about the network infrastructure, because I felt that this is really the arm and leg to deliver what 5G should be. And from our company perspective, how we actually can value add to get 5G done right from the beginning. And my topic here will be very much related to transport network, to see the evolution, where they are going, and also what they can do. And this is a big picture of what we have seen on the 5G. Actually, at the present moment, even though in the 5G specification, he has mentioned about the ultra low latency, and also the enhanced mobile broadband, and also the massive IoT, I'll call that. And today, actually, the use cases is very much surrounding the enhanced MBB. In this case, you can see that it is really neat to push the bandwidth up, because there are so many applications related. For example, in the broadcast industry, we can see that not only the standard definition or high definition is used, but in fact 4K and even 8K transmission is used. And even there's already in the stadium, 360 live streaming is taking place today. So this is really going ahead of everything. And if you look at the other two use cases, it won't come so soon, but there's really a plan to get it there. I'll show you the timeline as we go along. There are so many aspects that we have touched on spectrum, and we have touched on the wireless side. And I think that it's fair to match where my company is doing very well in the area of fiber. If fiber is too expensive in India, what is the value proposition and how we can help you to get a first time right deployment on the fiber per se. On the high speed, because the broadband is pushing to the limit, how do we see that this is being cooped up when it comes to the latest high speed, even to the extent of the 400G as well. And of course, our company also touching on expertise with cloud automation, plus the SDN NFV on analytics. So there are so many things that we can touch on, but today I'd like to focus on the network transformations. So this standardization of 5G that everyone has been touching on, Vision 2020. Nice. Let's see where this timeline is. It's actually here. So what's going to happen? Today, you can see that release 15 here, we got a non-standalone model. meaning that, as I mentioned earlier on, is touching on enhanced mobile broadband. So all the fixed wireless access is taking place today. What it simply does is that there's a new 5G, new radio is introduced, meaning that the RAN side is on 5G, but the core side is still using the legacy infrastructure of the core, which is the EPC. If you see the next step going forward, which is the good news, because mid of 2018, we see the standalone finally come out, and there's this 5G-C, which is the core of the 5G is being introduced. As we go further ahead, as I mentioned, that the low latency and the massive IoT is going to be come out, but it's going to take some time, because even initially it's supposed to be the end of 2019, but the 3GPP decided to postpone 3 months to make it March 2020 to come out with the Release 16 standardized. So this is a big picture of where the standard is going to. And if you look at the transformation from two aspects, the access side near to the user, you and me, and also the core side. On the access, this is where it's happening today. Fiber is already crawling everywhere, and on the access, you can see that between the radio head to the baseband unit, this is all fiber. In the past, it used to be coaxial cable. So what is next step? You can see that is centralizing of this BBU. Instead of putting it near to the base station, cell tower, is being centralized here. The evolution is taking place nicely because it is very much needed, and there's some transport is taking place between the fiber, which is being stretched from 100 meter to maybe 10 or 20 kilometer. And of course, the next generation of 5G, you can see that network slicing comes in, and also the machine age computing taking place, where the front haul is being split. And this is where we call the crowd RAN, or virtualization, is taking place. If I zoom in into this space, let you see. So this is a 5G transport architecture. First, the BBU, which used to be here, this BBU side, is divided into two functional elements. One is called central unit, and the other one is DU, distribution unit. What is this central unit is about is bringing the intelligence of processing, used to be in the core, near to the edge. With this central unit, or sometimes people call it the MAC, mobile edge computing, it actually shortened the processing time for the users to access to the network. So this is really the benefit of it, and the introduction of F1 interface, which is running Ethernet. And of course, with this desanctification, you can see that transport is being introduced, because the distance can actually be stretched up to 80 kilometers in this case. And there's already some latency specification down there to ensure that we are on track with the performance needed to be delivered on new use cases when 2021 or 2022 is concerned. So in short, I call it a front haul. This stretch, I call it a mid haul, and the back haul there. There's already some real network implementation in the world. EXFO being a global company, we spend 20% of our R&D into R&D, and we're actually working with the global operator. And you can see that this is one snapshot from the real operator that we have taken. From the China Mobile, by the way, from here to the edge, you can see that here, this is the expectation of the latency per segment. But in reality, when 2021 new use cases is concerned, autonomous driving, remote surgery, and things like that, the expectation of ultra reliable low latency communication is going to take like less than 1 millisecond, thanks to the processing power being bring from core to the edge. And if you look at the enhanced mobile broadband here, the VR and AR that is getting common nowadays is going to push the network to the limit by forcing the latency become lower and more stringent. What does all this mean to us is that today, let's say in India context, fiber is expensive, fiber is not everywhere, there's still microwave. How are you going to ensure a good ultra low latency can be achieved by 2021? So in this aspect, these are some of the guidance that is giving so that we can consider, for example, to leverage on the different transport in between this network to make it count. Big picture again. So you can see that from front haul to the core. So it used to be just a CP and offsite today, but with the 5G, you're going to see that the introduction of enhanced CP coming, and enhanced CP comes with two different rates. The Ethernet has also a subfraction of from 10G today going to 25 and even 50. So this is very new. And of course, we have TSN and MOS OTN coming into place. On the access itself, we see that the OTN is being leveraged with Flex-E started to be called everywhere. And of course, when we come to the 100G in the core, there will be even higher speed than 100G, which is 400G, and Flex-E channelization as well. So this is really happening from a high-level view. So if I may summarize on the front haul, really the advantage to go into the 5G, to me today is still a big challenge because first, we have to upgrade our infrastructure to enhance CPRI. And then this is what the enhanced CPRI stand for with the vendor behind that. It's basically a packet-based front haul, and it actually helped to improve the bandwidth efficiency 10 times compared to the legacy CPRI. So it's really a new element and into the 5G. And of course, to the challenges of the mobile network operator, MNO, it's really how to ensure a coexistence of 5G and 4G and 5G can come together and painlessly to migrate and to meet the use cases that is driven by the local community or the subscriber. This is really a big challenge because in order to do this, fiber has to be everywhere. Not only fiber everywhere, it has to be efficient and reliable with low loss because don't forget that the low latency is really critical in the deployment. Finally, if you come to meeting the new 5G low latency, there are various options, and EXFO being advantage to work with different vendors as well from a different continent. We actually come to know some have a good comparison result between active WDM, PON, fiber, Ethernet, and so on technology. And of course, on the mid and backhaul, the challenges remain like how to meet the ever-growing high capacity. In fact, today, 10G is already quite high speed. It's a luxury, but 25G is seen everywhere in 5G. And in China, they first proposed the 50 gigabit Ethernet line rate in the mid and backhaul. And higher rate is going up, definitely. And of course, besides having a high speed, you need to ensure the core don't drop. The throughput is reliable. And how to ensure high reliability, so it has to do definitely with the latency management in that sense. And finally, network slicing, add complexity to it, even though the advantages is to ensure every use cases or customer has their own QoS guaranteed. However, it actually means that to the operator, if you have a 500 customer, 1,000 customer, and more, the complexity to manage will increase. This is one example of where we actually validate the end-to-end performance. In this context is latency, frame loss, and also the jitter perspective. And in the core side of it, last but not least, we see that OTN is being introduced everywhere on top of a traditional Ethernet. And another big challenge is really the mushrooming of so many optical transceivers. If you actually go out in the field there, you can see that people are talking about almost every 3 months, 6 months, new transceiver is being introduced. How are we going to manage to cope with a variety of the transceiver? Especially we have got 10G transceiver, 25G, and now 50G. And on the 400G as well is even a new kit on the block where people are trying to figure out what is the best power consumption versus cost per bits choices when come to deploying the 400 gig E. And one of the elements inside for 400 gig E is actually the Flex-E for information. And if I may just summarize on what really happening is that we used to be talking about 100 gig E. We see the ramp up of it. But in fact, the 400 gig today is a new 100 gig. And what's next? We go to OFC in the US. We actually have seen a prototype of 800 gig and 1.6 tera already. So they are evolving too fast that in the past it used to be like 5 years and then 3 years, now 2 years and then 1 year. So you can see that it's happening too fast, and a lot of the new non-standard Ethernet rate is taking place to ensure that we can meet the demand by the customer accordingly. So in short, I would say 400 gig is definitely there in the core, and the interface for QSF PDD, for example, or OSFP are still undecisive whether which one will be predominant because they all have their pros and cons. And with the introduction of Flex-E, we can adapt to any of the Ethernet rate. So no longer require need to having a different hardware all the time, because Flex-E allow us to very flexible to manage the different application with a different bandwidth needed. So it's a very adaptable technology. So last but not least, I'll say that with that, bandwidth pressure is going to keep coming because new application, new business cases, as Sandeep has mentioned, will keep coming in. And IoT is already taking place today with sensor is being introduced. You go outside, you see so many tons of company trying to innovate and give the IoT. At the end of the day, it's going to be a world of massive IoT. And then the core network is going to be evolved. But is it going to be fast enough? That depends on the local demand and the timing. And also regulatory is important. For example, having the right spectrum and the right use cases with the right price, then everything is going to go in together nicely. And of course, the challenges won't go away with the different look at the new transceiver that is taking place just a mobile phone, every nine months you see a new launching. In the transceiver, you can say it's every 9 months is a new launching as well. So, and eventually the 5G transport is also evolving to become more intelligent, fiberized, as well as more efficient. And the keywords really for us is that EXFO, my company, is really seeing that how to ensure first time right deployment, how do we get it 5G done right first time, is actually having none other than ensuring the validation as well as testing is done, and to us is more important than ever before. Otherwise, how do we cope with ultra low latency when the time comes, as well as very sensitive and high demand kind of application. So I think with that, I sum up my session, and I'll pass back to Chairman.
It to the floor. So while you are getting your questions ready, we'll take a few from the floor. I'm just going to go back to Raymond. Raymond very interestingly talked about the introduction of this little box in the middle called the CU, and then you've introduced now this, the front hall, the middle hall, and the back hall. On the back hall here in India, fiberization is pretty much there because that's been the focus area of much of our operators because of the long distance connectivity. Where we face challenges is obviously what you define as the front hall and the middle hall. Is there a place for microwave in there while we're waiting for all of these great technology developments?
Actually, good point. I would say that microwave will be there, I would say. For example, when I look at the network infrastructure today, when 5G is being introduced, we have seen 5G RAN. But in fact, the LTE won't go away for next 10, 15 years. Because one of the use cases already today in router is a narrowband IoT, for example. This is leveraging on the core of the 4G. And in the process, for example, there are still many in Asia Pac in general. We still see microwave. There is a big dominant market out there. It definitely won't go away. In fact, I've heard that there's already upgrading to 10G of the speed in order to cope with, let's say, enhanced mobile broadband and so on. So definitely this is going to be one complement solution in addition to what I actually present on the wireline side of it. I agree with you that the wireless will be there as well, so long the demand is there and the cost per bits deployment, and it's very easy to put up a microwave to keep the network running, definitely.
Thank you. So let's open it up to the floor, so if there's any questions from the floor, otherwise I'll ask some questions, so this is your chance. Please, a microphone to the gentleman in the second row here, please.
Hi, I am Maleshwar from Invas Technologies. So I have a question to the panel here. The more of this 5G is an industry-driven approach, and artificial intelligence is also going to take a place. Do we really think that unless until the technology need or technology provision is already there in the thing, does really service provider to take forward into it? Unless until, let us say a surgery of a certain thing has to be done in certain milliseconds, or driving of the vehicles so faster without any damaging to each other. So that means it's all about an application oriented. So present service providers do not have much equipped with those of skill sets or establishments, we can say that way. Do we really think that it is going to take that quick unless until the industry at the other side is really grown up?
So I think if I might summarize, you're saying, look, are the operators going to be ready for rolling out 5G? And when is that? So I think we'll be talking about 2020, and operators have been talking about use cases, and we've heard some of that. But Rajat, maybe you want to talk to, are we going to be ready? Autonomous vehicles? Is that going to be one of the things, or are there other things that will be the context of rolling out 5G type services?
Thank you, Rajan. Actually, in my view personally, the operators are already ready to provide some kind of a service. 5G is only the next enabler. There will be many services which are in their infancy at this present point of time, which can be supported on the present networks. Maybe they will require slightly different architecturing, but it's possible to do. The question that you are really raised here is skill. And I think that was one of the points that I made also. Skill India is an extremely critical part. We have to be ready to move to skilling our people, and not just a small quantity, but a very large quantity is going to be required. Maybe over 1 million jobs are going to be required in this particular sector to be able to really realize the vision of 5G 2020. But to answer your question very simply, there will be some services which will be transitionary in nature, which will be supported on the existing 4.5G networks. And I'm using the phrase 4.5G networks, assuming that MIMO is there.
So just by way of context, the government has already identified 5 areas for use cases to develop: agriculture, education, health, traffic management, waste management, all been highlighted from an industrial policy. And so some of these applications don't necessarily require the low latency, high speeds that you're talking about. Already MIMO, which was targeted as a 5G, has already been pulled into kind of next gen 4G. So I think you'll see some of this gray area where, 4G is kind of moving forward into 5G, and that gray area, and then finally the movement into true 5G type applications, right?
I'll just give if I may just add, I'll just give another perspective on this. We are looking at a lot of products and services, but let me take it back a step and talk about just our simple plain voice communication. When we moved from 3G to 4G and from 4G into VoLTE, the transition has been dramatic. Today, I don't think more than 15 to 20% of our devices support VoLTE. So we are still not sitting there at this present point of time. 5G, you will not have that luxury. You have to have 100% VoLTE capability. And there are a very large number of complexities involved in VoLTE. Take, for example, roaming. So VoLTE and roaming in VoLTE are complexities which are still being worked on at a certain level. If my memory serves me, it was as recently as 1.5 years ago that roaming VoLTE was actually finally demonstrated between 2 operators between Korea and Japan. It was only 1.5 years ago. So there's still a long way to go. There's a lot of development. 5G is there, it's on the table. But there's a huge amount of work which has to be done to get there. And I think 4.5G, which is currently available with us, is an excellent service provider for those kind of solutions and actions that you're looking at.
So Sandeep, you have something to share? Yeah, I would like to add another perspective to what Rajat has mentioned. So 5G is not only about service provider or telecom service provider. 5G service provisioning will require the whole ecosystem to come together for delivering any particular service at any given point of time. You take case of, say, healthcare, or you take case of any IoT-based application. So there will be multiple players. So service provider will be there, then the IoT platform provider will be there, then further to that, There will be some end users also who will be there. So there will be, always there will be 4 to 5 providers who will be involved or who will be engaged in providing particular end services. So that is a completely different paradigm which it will bring. Rather than simply operator-centric, it will be a complete ecosystem-centric thing where a lot of players will be involved in delivering any service.
So time for one more, I think.
I have one more question.
Yes, please, towards the back, please. Do stand up, identify yourself and pose your question.
This is Manas Dutta, Chief Editor, Mouseworld Now. So an IT publication based out of Delhi. My question is, Mr. Mukarji had been pointing out that we need to really build up capacity for the 5G rollout. And more important, we need to skill ourselves so that there is a skilled workforce that will be carrying out the transition. So everybody has been talking about the challenges for 5G rollout, but my question is, what sort of opportunities, what are the new opportunities that 5G rollout would be throwing in the way of the telecom industry?
Opportunities for 5G. So please, any one of you folks, go ahead.
See, as I mentioned in my presentation also, I don't know whether you were there. So there are different business models which are appearing nowadays, which operators are just discussing which one to provide. So there is one different type of business model which is fixed wireless access from 5G, which can be very useful for enterprise customer who can be covered on a single unit with a single rooftop antenna. Second one is variable data rate and variable latency type of services. Now currently the packages which all the operators are providing is a fixed data rate, and beyond that data and a fixed price, beyond that data rate you are charged for the overage. Now with 5G's inbuilt technologies in 5G or supporting technology in 5G, there can be different data rates which can be given basis of the subscription. There can be different latency model. Then with network slicing, operators can always also provide SLAs also, which can enable high-speed services like 4K TV, etc. also, which can be delivered, which are not there earlier. And then network as a service is also another big opportunity, which is a much advanced version of current MVNO model, which will come. For example, you can partition your network capacity. A service provider can partition the network capacity and it can be leased to another key niche provider, say if it is for smart city projects. So then niche provider can lease the capacity from the service provider and do some focused applications, say industrial IoT. So there are various such health cases in healthcare, in transportation. So there are different type of opportunities and business cases which are being formulated. And release 16, which is due by end of year 2019, will give a lot of details about these business cases which are being built in 5G.
Let me hand off to Rajat, and with that we'll try and close the session. Thank you. Rajat, please.
Just to respond to your query about the opportunities, frankly, the user cases will build the number of opportunities which exist. There will be opportunities both at the operator side, and there will be opportunities in the ecosystem around us as well. Just take an example of IoT. If there is let's say there's a shop floor activity in Maruti Udyog, right? And this is an activity which requires an extremely intensive IoT operation. There's going to be a skill set which is going to be required there, which will understand the local automobile requirements in addition to the technology requirement. So please understand, this is specific to the user case. I give you an example of Maruti's system. So technology will be both automotive technology as well as the electrical technology or the communications technology. Build the same thing into, say, for example, the cement industry. So these are skills which are going to have to be developed based on user cases across the entire ecosystem. So opportunities, enormous, endless. Nobody can even visualize the end of it. That is, I think, the beauty of what opportunities, the right word you've used, exist in this Vision 2020 and 5G for India.
Thank you.
So on that happy note, opportunities, endless. Thank you very much, and appreciate your patience. Bye.
Thank you, panelists, for your valuable, in-depth knowledge. It will be a great pleasure for us to listen to you again in our future events. With this, we come to an end of yet another spectacular session. We sincerely value your inputs and appreciate the time and efforts involved on your part to contribute to the success of this conference. Thanks to all our delegates for their patience hearing. May I now request Mr. Rajan to present the mementos as a token of appreciation to all our distinguished panelists. Mr. Rajat Mukarji. Mr. Sandeep Kapoor. Mr. Raymond. And lastly, Mr. Parag. May I now please request Mr. Sandeep Shandalia, our colleague, to present this memento to our chairperson, Mr. Rajan S. Mathews.